So we're going to discuss linear inequalities today, how to graph those things, even what they look like, what they're supposed to look like, and then how to do it in a way that should be pretty easy for you. Would you like to learn all that today? Yeah. Of course you would. Well, let's review what it means to be a linear equation first, and then we'll translate that into linear inequalities. Hey, by the way, the key word in linear, what's that mean? So when we're talking about linear equations, what we're talking about are these equations that when I graph them, they're going to make a straight line. Well, not a curving line, just a straight line that goes on forever and ever and ever. That's what we mean here. So a linear equation, we really had two forms. We had this one, or we had this one. Hopefully you're familiar with those two forms. What's the first form called? What is that?
Standard form.
Good, that is standard form. And this one down here, the y equals mx plus b, what's that one? Slope-intercept. And if you graph forms of equations that look like this, what you're going to get out is just a straight line on an xy axis. Now, normally, we like to work with this one, right? Because we know that we don't need tables to draw any of these lines. I do not want to see you drawing tables anymore. We're past that. We know we should be able to go to this intercept, use a slope to find the next point, and we graph that in like 5 seconds. I mean, that's really, really quick. Very much faster than a table is. However, I haven't shown you how to graph a line using standard form. Maybe no one ever has. I'm going to show you that today, that sometimes we can use standard form to graph a line like that. It's fast. It's kind of nice. Have you ever seen that? If you have, well, then you're in for a little review. If you haven't seen it, this might be something new for you, a different way to graph a line. You'd like to learn that, yeah? Kind of nice. So if these are linear equations, the only difference we have from a linear equation to a linear inequality is, well, let's change that equal sign, and then we have linear inequality. So if these are linear equations, all we're doing for a linear inequality is changing that symbol. So instead of the equal sign, we could have less than or equal to some constant. And remember, this inequality here doesn't necessarily have to be less than or equal to. You could have a less than, or greater than or equal to, or greater than. Any of those 4 symbols that we've been working with in this class, it could be there. So let me give you your very first example of a linear inequality. Hey, firstly, what form would that be in? Is that standard form or slope-intercept form? What do you think?
Standard.
That's definitely standard form. It's got both variables on the left-hand side, the constant on the right-hand side. So we are dealing with our standard form here in this case. Hey, what's a solution? You know, before when we dealt with just regular old equations, we could solve them. We had like x equaled something, y equaled something. What's a solution for our case up here? What is a solution here? How many variables do you have? So if I say x equals 3, is that enough to make a solution here?
No.
So what's a solution?
2 answers?
2, well, you're going to have 2 numbers, right?
Yeah.
You're going to have x equals something, and are you also going to have y equals something?
Uh-huh.
Hey, when you have x and y put together, what is that? When you have x and y put together, what's that?
A set. Point.
That's a point. Our solutions here are going to be points on a graph. Wait a second, just think about that for a second. Shouldn't that make sense that our solutions are point? Aren't we graphing this thing on an xy axis? So our solutions, they're points. It's x comma y, and that set of numbers, that ordered pair, has to be a solution to this inequality. Are you guys with me here? Stay focused. I know it's Monday. I know it's early. But stay focused on this stuff. This is kind of an important lesson for us. So we have these things called linear inequalities. We know they look like this with inequalities here instead of equations. However, we're still going to be getting straight lines. The solutions are still going to be ordered pairs. It's just a set of numbers. It's x comma y that work or that make this inequality true. That's what we're looking at getting here. So a solution is an ordered pair. xy, the solution is an ordered pair xy that makes that inequality true, or that satisfies that inequality. Hey, let's try a few. Let's try the point 0, 0. What I'm asking here is, let's try 0, 0. Let's plug it into our inequality. Let's see if it's a solution or not. Can we do that together? What's our x value?
0.
What's our y value?
0.
Sure, they're both 0. That was an easy one. Okay, let's plug both those in. 3 times 0 plus 5 times 0. How much is this side going to be?
0.
Are you with me on this, folks? Okay. So yeah, we have 0 plus 0. Hopefully that's still 0. We get 0 less than 15. Is that true or is that false?
Sure, it's true.
You have to be very, very, very good at realizing whether these things are true or false, because this ultimately is how we're going to be able to graph these linear inequalities in about 10 minutes, okay? So you have to be really good at telling whether things are true or false. This one is definitely true. Didn't you have to be good at that? Okay. Definitely true. For sure, 0 is less than 15, right? If you have $0, you have less than $15. So this is a true statement. Very true. Let's try a couple more. Let's try 1, 2. Let's try 1, 2. In this case, how much is our x?
1.
Our x is hopefully just 1. How much is our y? 2. Plug those numbers in. See what you get on the left-hand side. So we're going to do 3 times 1. We'll do 5 times 2. 3 times 1 plus 5 times 2. How much do you get there? Is that a true statement? Okay. So far, if we've made a true statement, this is a solution. This is a solution. Let's try a couple more. Let's try those ones. Let's do the 1, 5. Here it says our x will be 1. That's our x coordinate, right? It says our y will be 5. Let's plug that in because that's our y coordinate. If we plug in 1 and 5 respectively for x and y, 3 times 1 gives you how much?
3.
5 times, that would be 5. 5 times 5 here gives you, so altogether we have true or false?
False.
Definitely false. So is this one a solution?
No.
No. So the ones that make true statements, those are solutions. The ones that don't make true statements, or in other words, make false statements, those are not solutions. Once you do the last one on your own, see if you have a solution or not, okay? You don't have to say it out loud, just do it on your paper. Three times negative 2 plus 5 times 10. I'm thinking that's how much? 44. True or false? Definitely false. How many people feel okay on determining whether a point will give you a solution or not? You like that? Now, one note about this, I want you to look at this for a second. Did any of these actually equal 15 when I plugged this in? What that means is this. This is interesting. I hope you're kind of figuring this out. If I had a linear equation, watch on the board here real quick. Don't change your paper, but watch me change my board here. If I had that, do you realize that none of these would be solutions? None of those. They'd have to be equal to, right? And that would represent the points that are actually on the line. You with me? Or actually, it'd be this way. On the line. Well, if none of these points are actually on this line, yet they are still solutions to this inequality, what that means is this. These points are not going to be on the line. They're either going to be, watch my hands here, they're either going to be above the line, or they're all going to be below the line. But what this represents, all these solutions are either on one side or the other. So our solution set is not necessarily just going to be a line. It's going to be an entire, what's called a half plane. Half of the graph is going to be shaded in, and half of the graph is going to be unshaded. So these solutions represent an entire half of a graph. You with me on this stuff? They're not on the line. In fact, no point, because that's not even equals to, is going to be on this line. They're all either going to be above it or below it. But those represent our solutions. That's a whole bunch of points. That's a lot of stuff. You with me? So are these actually on the line?
No.
They're either all above the entire side or all below that entire side. One side's going to work, one side's not going to work. So let me make that note for you so that you can remember that when you're graphing these things. So note, there's more than one solution. In fact, an entire side of the line, half plane, is going to be a solution set. There's more than one solution. In fact, one entire side of our line, and that's called a half plane, is going to be our solution set. One entire side. That's interesting. You've never seen that before in mathematics. You've never seen where one entire side of an XY axis is a solution. And you're seeing that now. That these solutions are more than just the line. It's all the points either above or below that line. We're going to find out how, in fact, we will find out what the solutions are. Bless you. Would you like to see how to do that? Let's graph one of these. It's kind of exciting, right? This is brand new stuff for you. Have you ever seen this before?
No.
Well, if you have, well, forget you guys then. All right? You've seen it before. Whatever. Just pretend. Pretend this is new. Now, most of you have never seen this before. Or if you have, it was very brief and you really didn't get into the whole why this stuff works. But now we will. Well, as is my usual, I'm going to give you an example, and I'm going to give you some steps on how to do this example. Before I do that, I want to make sure there's no questions. I'm going to have to erase this for our steps. Are there any questions on this stuff? So we find out that these things are straight lines. However, our solutions are not just the line itself. Our solutions are half plane, either above or below that line. Well, let's go ahead and let's graph this thing. First, a couple questions. Is this linear? Is that linear? And yeah, before you really answer that, maybe you don't know how you determine whether something's linear or not. Does it have two variables? Good. Are each of those variables raised to, at most, the first power? Yeah. Well, that's linear. All right, that's what tells you this is going to be a linear graph here. If we had x squared, it wouldn't be linear. Y squared, it wouldn't be linear. But we have an x, we have a y, they're all both to the first power. That's going to be a linear graph for us. Is it an equation or an inequality?
Inequality.
Definitely. It doesn't have the equal sign. That means we're not an equation here. We're an inequality. That means our solutions are going to be a half plane. Well, let's look at how to graph this. The first thing we're going to do a little cheating. We all like to cheat, right? I mean, come on. Everyone likes to cheat. No, I'm just kidding. No one likes to cheat. But we're going to do a little bit of cheating up here. We really don't know how to graph this thing like it is, right? Because we never graphed inequalities. But we have graphed equations before. So here's a little cheating. Now, I have a lot of students who always make this mistake. They say, well, if you do it to this inequality, you do it to all inequalities, right? Well, I'm going to do something up here, but this is only in this context, and we're only doing it temporarily. What we're going to do temporarily, we're going to replace this inequality with an equal sign, just temporarily. Do we do this all the time? No, no. Just when you're graphing a linear inequality, okay? This is it. It's the only time you ever do this. Are you going to do it with absolute value inequalities? No. Please don't do that. No. We don't want to do that. We want to just do it for right here, just so we can graph the line. All right? That's the only time we are ever going to do this. We're going to cheat just a little teeny bit for this one context. Nod your head if you're with me. You ever going to do it anywhere else besides this? Don't want to do that. So step one, we're going to replace the inequality with an equal sign just temporarily for one little step. Okay, so let's give that a try. So we're going to have, instead of x minus y is greater than 3, let's do x minus y is equal to 3. This is our step number 1. Here is why we do this. Here is why we do this. You see, the reason why we use that equal sign just temporarily is because we know this thing is going to be a straight line. We also know that the solutions are going to be either above or below, so we'll have to deal with that in a little while. We're not going to deal with that right now. All we want to do right now is get the straight line on the paper. You with me? That's our goal. But there's really no way to find out our intercepts if you have an inequality. The only way you find out intercepts is if you have something equal to it. That's why we're doing this step, just so we can get the line on the paper. Okay? So we're going to use this step to do the next thing right here. This is under step number 1. And we're going to find the x and y intercepts. So we're going to replace inequality with the equal sign temporarily, and then we're going to find x and y intercepts. Okay, how in the world do you do that? This is one way that you can use standard form to graph the equation of a line very, very quickly. If you've never seen this before, this is going to be kind of neat for you. It's not slope-intercept. We don't even have to worry about slope-intercept. You could do slope-intercept here, couldn't you? You could just add, or well, actually subtract y and subtract 3, or subtract x and divide by -1. You could get slope-intercept out of this. It'd work out exactly the same. If you want to do that, that's fine. What I'm giving you is another tool. Okay, this is another tool in your little toolbox here that you can use, and it's pretty quick. You ready for it? Here's what you can do to find your intercepts if you have standard form. To find the x-intercept, underline x-intercept. To find the x-intercept, I want you to think about this before I write anything up on the board here. Here is my xy axis. Of course, this is x. And this is y. X is our horizontal, y is our vertical, for sure. If I want to find the x-intercept here, look at the board here with me. If I want to find out where this crosses the x-axis, can you tell me what is the y-coordinate? What is the y-coordinate of every point on here? For instance, This point would be like 1 comma what?
0.
1 comma, not 1. 1, 1 would be right here. This is 1 comma.
0.
This is like 2 comma what?
0.
And this is negative 3 comma what?
0.
What's the y-coordinate of every point on the x-axis?
0.
So if I want to find out where this crosses the x-axis, I'm going to plug in y equals...
0.
Let's plug in y equals 0. Watch what that does for us as far as the standard form. Check it on board. If I plug in y equals 0, this is going to be x minus 0, right? Essentially, look what I do. If I plug in y equals 0, if I just cover that up with my hand and rewrite the rest, if I cover up with my hand, that means it's 0, right? It's gone. Just write the rest. If I cover y with my hand, I get x equals 3. Let's write that. You've just found your x-intercept. That's kind of neat, right? Kind of cool. So what we're doing here is the covering up. We're not tricking the problem at all. This is not a trick. What you're doing is you're substituting in y equals 0. You can watch and see that this happens every time with your standard form. We do x minus 0 equals 3. What's x minus 0? It's just x. 3 is just 3. It didn't do anything for us. We just completely eliminated out the y. So on this problem, we say to find x-intercept set y equals 0, essentially we're going to cover up y with our hand and we're going to rewrite the rest. Notice what variable is left when I cover up the y. What variable is left?
X.
And we're looking for the x-intercept, right? That's the intercept. Whenever you have that variable equals a number, that's the intercept that you're talking about. Even with constant lines, when we had like y equals 2, that was our intercept, wasn't it? It was horizontal at 2. Here we have our x-intercept. X is 3, we're going to go over to 3 and put a point in just a bit. So what we're doing here to find our x-intercept, we're setting y equals 0. Essentially, we're going to cover y and write the rest. Well, that's great. We have the x-intercept. Let's work on now the y-intercept. To find the y-intercept, so this was our x-intercept. To find the y-intercept, think about the y-axis. We want to now find out where our lines are going to cross the y. Can you tell me what's the x-coordinate for every point on this axis? This is what comma 0, and what comma 1, and what comma 2, and what comma negative 3.
3.
3?
Oh.
This is 0, 1, 0, 2. This is 0, 3, 0. This is 0 something, 0 comma something. So every single value along this for x-coordinate is 0. It's 0 comma 1, and 0 comma 2, and 0 comma negative 3. Are you with me on this, folks? So we're going to do exactly the opposite thing that we did up here. To find the y-intercept, we're just going to set x equal to 0. Let's try that, okay? If we set x equal to 0, what are we going to have up here? Set x equal to 0 and read off what you have. Good. Oh, we still have a negative y. Do you guys see the negative y? So if I cover up the x, what I'm doing by covering that up is I'm saying x is now 0. And that means I'm going to be on the y-axis. So if x is 0, I cover that up. I can't do this. Can't do that. What's the mistake there if I do this?
It's the negative?
Yeah, that's still there, right? I didn't eliminate this minus, or in this case, when it becomes 0, a negative. It's going to be negative y equals 3. Negative y. Am I looking for negative y equals 3?
No.
So, say it again?
Divided by negative 1.
Sure, yeah, if I have negative y equals 3, I want to get positive y. Let's divide that by negative 1. I'm going to get y equals negative 3. That's my y-intercept. By the way, I know it took us about 10 minutes to kind of go through this, but can you see that this is very, very quick? I mean, you do this, you go, oh, let's see. I write equals. I go, what's my x-intercept? Make sure there's only an x left. If you want the x-intercept, you have only an x left. X is 3. Great, x-intercept. If I want my y-intercept, let's do that. Maybe do one extra step besides that, divide by -1. Y should be the only thing left. Y is -3. Perfect. That's pretty easy to find those intercepts. Once we have our intercepts, by the way, are there any questions on how to do that? So our goal right now is temporarily set equal to 0. I'm sorry, set it equal, not 0. Then set these each equal to 0. Y for x-intercept, x for our y-intercept. Essentially, what that is you're just covering up the y, or you're covering up the x, and you're rewriting your equation. After we've done that, we have our intercepts. There is another step. We're going to graph our line. But there's some rules on how to do that. Hey, do you remember when we did the interval notation, and we did the, actually more than this, the piecewise function. Remember those piecewise functions? And sometimes we had the open circle, and sometimes we had the closed circle. Do you guys remember that? When did you use the closed circle? When it was equal to, or when it was not equal to?
Equal to.
And the open circle was when it was not equal to. Are you with me on this? We have the same basic idea for our lines. Here's how it works though. We don't just have a whole bunch of circles. What we have is either a dotted line, or we have a solid line. The solid line, what do you think that's going to be? The equals or the not equals? That's equals. The solid line is like the solid circle, like the closed circle, okay? So if you're talking about the equals, you're going to be using a solid line. With me? If you don't have the equals up there, we're going to be using a dotted line. That's like the open circle. So if it was like closed circle, solid line. Open circle, dotted line. Those things kind of go hand in hand there. So we're going to graph our line, but with two rules up here. If we have a less than or a greater than with no equals, we're going to be using a dotted line. Or a dashed line. That's fine. That's what I use. Dotted line for less than or greater than, and a solid line for the equals. Are you ready to graph this thing? Let's try it. Let's do it. So we have x minus y is greater than 3. We just temporarily did this step to get our intercepts. Right now we're going to go back up to here and look to see whether we graph this with a solid or a dotted line. Are we going to be using a solid or a dotted line here?
Dotted.
Definitely. Or a dashed line. That's really what we mean. Let's go ahead and do this then. Here's how you graph a line with your standard form. After you found your intercepts, this kind of tells you where to go. This says you're going to x equals 3. Can we all go to x equals 3? That's going to be from the origin to the left or to the right here, folks. So 1, 2, 3. Let's just put a point right there. Okay. Y equals -3, that's our other intercept. Where we're going to go for y equals -3. 1, 2, 3. Can you connect it? Let's make a line. That's a pretty good line. I didn't even have a little ruler thing. Is this right? Why not? Y dashes. Okay. Yeah, you can't do that on your paper, can you? That'd be awesome if you could, though. Now that's our line. Let's see if we know how to get there. First thing, we are substituting an equal sign temporarily. We're finding each of our x and y intercepts just by covering up, rewriting the rest, and then solving. We put those things on our graph. Just go over the x-axis, go to 3. Y-axis, go to -3. That's what those variables are telling you to do. Make your line with a dotted or a dashed line if it's not equal to. Notice we're setting these all. This is why we don't use this all the time, right? We have to go back to this one. Go back to this. If it's equal to, we make it solid. If it's not equal to, then we make it dotted. But we're not done. Because I told you at the very beginning when we looked at the solutions that our solution set isn't just going to be a line. In fact, look at this. None of our solutions on the line are actually. That's what the dotted signifies. It's like an open circle. You can't actually get there. What we need to determine is whether the solutions are all of these points up here or all of these points down here. You with me? It's going to be half of them. It's either going to be all of these over here that are all going to work or all of these over here that are all going to work and the other side won't work. That's going to be our final step here. Our final step is going to be to check one point. You don't have to check a whole bunch, and that's kind of nice. You just have to check one point. Because if this point works here, all of these points are going to work. If this point doesn't work, all of these points are not going to work. What points will work? Good. So you don't have to check 2 points. You don't even check 3 points. Just check one. What now?
Can you say that one more time?
Sure, I can say that one more time. What we're going to do is check one point on this graph. Pick any one you want. Does it really matter? We're going to pick a nice one in a little while. But pick any point. Let's say that this one is the point that you picked. 1, 1, okay? Let's say that's 1, 1. If this point works in your inequality, every point on this side is also going to work. And we're going to shade that entire side. You with me? They'd all work.
If it's true.
If it's true, yeah. But let's say that this is not true. Let's say this is false. What that means is every point on this side is also going to be false. You with me on that? But if these are, one side has to be true, one side has to be false. If this side is false, this side is true. Okay? So you just check one point. That's why I said at the beginning of class you'll be very good at determining whether inequalities are true or false. Because you're going to plug in one point. If it's true, you shade that side. If it's false, you shade the other side. Does that make sense? That's our ideas here. Do you guys need these steps anymore? I'm going to erase them because our third step is kind of long and I have to write out all these instructions for you. So step number 3, you're going to check one point that is not on your line. Can I check a point on the line? Well, that'd be kind of silly, right? Because if I check a point on the line, would it tell me which side to shade? Not so much. So we're going to check one point that is not on our line. Check one point not on the line. Now, there's one point that we should try to use all the time if we can. What point do you think that is?
0.
Why would we want to use 0, 0? Yeah, it's easy. We don't have to even do any math, right? If you pick 0, 0, what's 0 minus 0? Hey, it's 0, right? That's nice. That's very easy to check. There's only one instance where you cannot use 0, 0. Say that now? Sure. If our line goes through the origin, through here, then we can't use it. You with me on that? Because then it wouldn't tell you a side. Then you pick another one, you can do like 0, 1 or something like that. That'd be fine. Something on the y-axis. So you can make zeros if you like. I'd love you to use 0, 0 every time if you can. If it goes through the origin, then of course you have to pick another point, pick 1, 1, or anything that you want. It really doesn't matter as long as it's not on that line. So we're picking one point on the line. Try 0, 0 if you can, or use 0, 0 if you can. And here's the rules. If the point works, if the point makes a true statement, you're going to shade the side of the line, the half plane, that point is on. If the point makes a true statement, shade the half plane that the point is on. If the point makes a false statement, you're going to shade the half plane opposite where your point is. Okay, it's a whole lot of writing. What we're basically saying is this: you're checking a point, just one point. If it works, if it's true, shade that side. If it doesn't work, if it's false, shade the other side. That's all I'm saying up here. Okay? And the half plane just means the side of the line. So what we're going to do after we've set it equal, after we've found our intercepts, after we've graphed our line with a dotted or solid line, depending on whether we're equal or not equal, we're going to write a little word down here. We're going to write check. And you're going to tell me the point that we are going to check. What point is that in this case? Can we check 0, 0?
Yeah.
Yeah, it's not going through there. Why not? So we're going to check 0, 0. And here's how we do it. We just take 0, 0, and you're going to plug this into the equals one or the inequality? Which do you think? This was just temporary. Okay, this was only for one reason. It was just to make your line. We're going to plug this back into your original inequality. So check one point not on the line in the inequality. So we should have, instead of x, 0, instead of y, 0, and we're checking to see if that's greater than 3. What do we get on the left-hand side, everybody? This is where you got to be good at this. Is 0 greater than 3? Is that true or is that false?
False.
Definitely false. Okay, need a show of hands if you're okay getting down to that far. Good, okay, that's fantastic. Now what does this tell you? Here's another important part. These are the two key points. I can typically get everybody to get down to this part, right? You draw the line, no problem. This is old school stuff. Old stuff. Old school. That's old school. But here's what you did. You just checked this point. Identify the point that you checked. Okay, identify the point you checked. You just check the origin. Most of the time you'll be able to check that. The only time you cannot check that is, well, if it goes to the origin, you can't check that. We just check the origin. Did the origin make a true statement or a false statement?
False.
Okay, here's the key point. If this had been true, we would be shading this whole side. Are you with me on that? If that had been true. Was it true? So what side are we going to shade? We're going to shade this side. We're going to shade the other side. If the side doesn't work, if it's false, it says none of these points work. You know what? You can spend all day checking points. If you check 1, 0, you know what? It's not going to work. Negative 2, 2, it's not going to work. None of these points is going to work. Every one of these points will work. Check it out if you want to. Try 5, 0. You try 5, 0, 5 minus 0 is 5. Is 5 bigger than 3? Absolutely, you got it. So this whole side is going to work out for us. The way we represent that, we're just going to shade it. It goes on forever. That's a whole half of a plane, half graph. So we check the point. If it's true, we would have shaded that side. If it's false, you shade the other side. Raise your hand if you feel okay with that. Good. Now, do these really take 30 minutes to actually do? No. No, they're pretty quick. In fact, we're going to do one in about 5 minutes right now. Okay, you know the steps. So, you have them on your paper. What's the first thing that we're going to do here, folks?
So we change the
Temporarily, this is the only time you ever do this. Set it equal to 0, you're right. This just allows you to find your intercepts. So we're going to find our x-intercept first. So write out x-intercept. And down here we'll have the y-intercept. To find the x-intercept, what do I cover up? Yeah, all I want the x. I just want that term. So if I cover up the y, that means I'm having y equals 0. We're going to rewrite the rest. What's the rest when I cover that up? What equals 4? Hey, you're done. You have the x-intercept. Let's find the y-intercept. Y-intercept means you're taking x equals to 0. That means I'm going to cover up which term here? This one? This one. Option 1 or option 2, like an optometrist? 1 or 2? 1. Yeah, this one. I need that sign with it. So I'm going to rewrite the rest. Negative 4y equals 4. Is there anything else I have to do with this one? I want you to know something. This is kind of cool about standard form. And don't you like the standard form graphing? It's kind of nice, right? Just cover two things up. Even if you got a fraction, you could still do it, couldn't you? Just go up to a fraction, no problem. If you had 3 halves, go over 1 1/2. It's still possible. If we divide by negative 4, we're going to get y equals negative 1. We're now ready to graph our line. Here's x, here's y. We already have an x-intercept. Bam. We've already got a y-intercept right there. Let's graph this. Where am I going to go on the x-axis? 4 to the right. Okay, I can do that. 2, 3, 4 to the right. I'll plot myself a point here. Where's my y-intercept, ladies and gentlemen?
Negative 1.
I can do that too. Up or down?
Down.
Are we going to plot this with a solid line or a dotted line?
Solid.
Why solid? Are you sticking with me here?
Mm-hmm.
See the solid line? Solid line says, oh, solid line right there. Solid line. So, we temporarily set it equal. We cover up everything except the x to find the x. We cover up everything except the y to find the y. Don't have to do anything here. Have to just divide by negative 4 there. You get negative 1. X, 4. You got it. Y, negative 1. You have 2 points. You only need 2 points to make a line, don't you? Make your line. And then we do, we're done? If you don't shade these things, do you have the right answer?
No.
What you've done here is you've graphed this. I want you to graph this. Okay, that's a big difference there. This you did in maybe even Math 8 or your pre-algebra. You did this. We're here. The only other thing is you got to shade it, but you do have to shade it. So you're going to write out check. And you're going to tell me the point that you are checking. What point are you checking here?
0.
If it doesn't go through the origin, check 0, 0. That makes an entire side of your standard form equation 0. We like that. So we're checking that point. So we're going to have 0 minus 4 times 0 is less than or equal to 4. So 0 is less than or equal to 4. So you got to be able to tell me whether that's a true statement or a false statement. What do you think? Is 0 less than or equal to 4? Absolutely. Yeah, that's definitely true. 0 is less than $4, right?
Yeah.
Definitely true. Well, here's what we did. We just checked that point. So know the point that you checked. Did this point work?
Yes.
If this point works, that means every point on this half plane is also going to work. You follow me? Try some if you want. Try 1, 1. 1, 1 is going to work. 1 minus 4, oh, that's negative 3. Negative 3 is less than 4. That's going to work. Every point is going to be just the same on this side. Every point over here is not going to work. None of these things are going to work. So are we going to shade the, we'll call this the top. Are we going to shade the top or are we going to shade the bottom?
The top.
Definitely. It worked. We shaded the side of the half plane that that point is on. We're going to shade this whole thing. By the way, a couple things I want you to notice the difference here. Will the points that are on the line work in this inequality?
No.
On the line.
Yes.
Yes, because it's solid. Will the points on this line work in that inequality? No, that's the difference, okay? The open circle or the dotted line means you can't actually get to those points. You can get right up to them. The solid line or the solid circle means you can. So these points will work in that inequality. How many people understood what we talked about today? Good for you. So when we're doing our graphing linear inequalities, our first idea is, well, we want to make sure we temporarily set this thing equal to 0. That way we can find our x and y intercepts and graph at least the line part of it. However, we know that we're not just graphing lines here, we're actually shading a half plane. So it's either going to be shaded at the top half or the bottom half of our graph, and that's telling us our whole solution set. So the first thing we're going to do, let's set this thing equal to 0 temporarily. By the way, do we ever do this any other time besides right here? The only time you're ever going to switch an inequality to an equal sign is right here. We'll do our 3x plus 2y equals 12 just for a second, and this is just so that we can find our x and y intercepts. Ladies and gentlemen, in order to find the x-intercept, what do I do? Good, okay, so if I want the x's, I better cover up everything except the x's. That makes sense. So that's gone. I'm just going to rewrite what's left. So x-intercept, we cover that up, we write what's left over, that's 3x equals 12. And there's at most one step. There's at most one step after covering up in order for you to find the intercept. In our case, what is that step? Yeah, we'll do that. Divide both sides by 3. And all of a sudden we have our x-intercept, and that's 4. Not so bad. So here's our x, here's our y. Here's what we know already. If we just found our x-intercept, we just found where our graph is going to cross the x-axis. That's this one. Where's it going to cross the x-axis? Yeah, it tells us. So we're going to go over to 4. And we'll put a point right there. That's how you use your x-intercept. You just put it on the x-axis. That's half of your graph right there. You only need 2 points, right? We already have one of them. Now, let's go ahead and find the y-intercept. What do we do in order to find the y-intercept? Good, and setting x equals 0 means we're just going to cover that up. If we want the y-intercept, let's cover up everything except the y. One thing on this, make sure if you're going to cover up everything except the y, I know that's a plus sign, it really doesn't matter in this instance, but don't cover up the sign, because if that was a minus, that would change our problem we saw it last time. You with me on that? So cover up just the x term and write what's left over. So we have a 2y equals 12. We'll do the same process we did for the x-intercept, that's just divide both sides by 2. We get y equals 6. If y equals 6, that means, well, are we going to go up or down on the y-axis? Good. Put a point there. Hey, you only need 2 points to graph a line, right? We've got 2 points. Let's graph our line. This way's harder. Do it this way. It's harder. I don't know why. The other ones this way look good, look great. Those ones have a little kink to it. Wait, what now? Why? Okay, so why is this not right? What would solid represent?
Equal to.
Yeah, the solid would represent equal to, because it would mean that the line is actually included in our solution set. It means that we could go up to the line and actually include the line. If we're not equal to, it means the line itself is actually not included. We can go all the way up to the line, but the line itself is not in our solution set. So in order to represent that, if we do not have an equals, remember, we're not looking here, right? That was just a temporary step, just for like 5 seconds, so you could write your x and y intercept. We don't ever use that again. We look back up here that says it's not equal to, so I definitely need a dashed line, or a dotted line, either one. And we're done, right?
No.
Why are we not done?
You gotta check it.
Okay, we have to check one point because, yes, we have to shade it. We've got to shade half of this graph. Either the top half, we'll call this the top half. Either the top half is going to be shaded, representing all these points, or the bottom half is going to be shaded, representing all those points. One of those halves is going to work. What point do we always like to check, ladies and gentlemen? Okay, can we check 0, 0 here?
Yes.
Yeah, absolutely. As long as it's not actually on the line, you can check it. So we're going to write down here, check. we're going to put the point that we're checking. In this case, of course, we're checking 0, 0. Now, where do you check 0, 0? Do you check it in your original inequality, or do you check it in this equation? What do you think?
Original.
Yeah, this was just for a second. We're using that one. So check that point. We have 3 times 0 plus 2 times 0 is greater than 12. It's nice because this right here, this makes one whole side of our inequality equals 0. That's why we use that point if we can. 0 is greater than 12. What do you think? True or false?
False.
Definitely false. Well, here's what that said. If we checked 0, 0 and it was false, did that point work in our inequality? Are any of these points going to work in our inequality?
No.
Okay, so are we going to shade, let's call this the bottom, are we going to shade the bottom half or are we going to shade the top half? If this point doesn't work, none of these work, all of these work. We shade that. Go ahead and give that a try with that example. So I want you temporarily setting that equal to 0, equal instead of inequality. I want you to find your x and y intercepts, graph them on an xy axis, use the appropriate type of line, check the point and shade. That's the whole process. Good, lots of good work so far. So see x and y intercepts, see the appropriate type of line, and some good shading. We're going to start up here in just a bit. Okay, so the first thing I hope you did was temporarily change that inequality into an equal sign. What that lets you do, only for one reason, we're just finding x and y intercepts with that. So we'll say 3x minus 6y equals 12 just for a second. We'll cover up some appropriate things to find the appropriate intercepts here. So if we want to find the x-intercept, which we'll do first, we're going to cover up the y term. That means we're plugging in y equals 0. That's really what we're doing. We're just going to write the rest. By the way, would this still work if that number wasn't divisible by 3? What if that was like a 16? Is that going to be okay?
Yeah.
You just have 16 thirds, that's going to be 5 1/3. You can still graph that on a graph. That'd be okay. So we divide both sides by 3, and we get x equals 4 again. Now for our y-intercept. Same idea, we still want to set our x equal to 0 this time. That means cover up our x term, not with the negative covered up, without the negative covered up, because this sign goes with this term. So we're going to cover this up and do negative 6y equals 12. Did y'all do that?
Yes.
I mean, we've got your intercepts of 4 and negative 2. Good, that's fantastic. And we can start graphing this. So we know we cross the x-axis at 4. We know we cross the y-axis at negative 2. Our lines are going to intersect with both those points. Do I need to make that a dashed line, or do I leave it solid in this case? Good, that's worth a couple points on your test. You know that that's a solid line versus a dashed line. And it's pretty easy to tell, right? We just go right up here. If it's equals, keep it solid. If it's not, make it dashed. We check 1 point. If it's not on the line, we're going to check 0, 0. It's the easiest one to check. So over here we put check 0, 0. And what we're doing is essentially plugging in 0, 0 for our x and our y coordinates. So, let's see. True or false? Definitely true. If it's true, you shade the side that the point you just checked is on. You shade that half plane. So 0, 0 worked. It represents all these points work. So we're going to shade this entire half plane. Would you raise your hand feel okay with these two examples? Cool. Now let's look at what happens at something like this. This doesn't look a whole lot like these examples. You with me on that? Can we do the same thing that we did over here? Well, first thing, if you're going to try to do this, you're going to have to get it in the correct form. How can I get it in the correct form to use this? I could subtract y and get 0, or I could subtract 3x from both sides. Either way would work, okay? Let's subtract 3x. Don't write this down. I want you to see something. All right? Don't write this down yet. I want you to see something. If I subtract 3x, I get negative 3x plus y is less than 0. I'm writing it that way because that's standard form. Do you guys see the standard form? Mm-hmm. Now, let's try to do this method with that problem. You ready for it? Here's what you do, right? You'd write x-intercept. You'd write y-intercept. In order to get the x-intercept, you would cover up the y. Well, you'd set it equal, right, firstly. You'd cover up the y and you'd get negative 3x equals 0. True? And you would get x equals how much? 0. Definitely, divide by 3, negative 3. You get 0. But then in order to get the y-intercept, you'd cover up the whole x term, wouldn't you? And you'd go, oh, okay, y equals 0. Wait a minute. Wait, hang on. Let's graph our intercepts. X equals 0. You know where x equals 0 is? You know where y equals 0 is? Uh-oh. How many points do I have? How many points do you need to graph a line? 2. Can you just go, oh, there's 1 point. I know it looks like this. Yay! No. No, we can't do that, right? Because there's an infinite number of possible lines you can go through that. We have no idea how that looks. This one's not going to look like that. In fact, this one's going to look much steeper than that. This is a slope of 3/1. So you're not going to have that look of a line. So what I'm trying to tell you here is that this method works great if you have a number here and here. However, there's certain cases where you cannot use this cover-up method that I taught you, the standard form version of graphing a line. Are you with me on this? You can't do that. So write this down. You can write this example if you'd like, but make sure you write this down. If you have ax plus by less than, greater than, less or equal to, greater than equal to, whatever the inequality is, and a 0 over there, you cannot use the standard form version of graphing a line. Because look what happens, folks. If you cover this up, you get 0. If you cover that up, you get 0, right? That means you get the same point twice. There's no way to graph a line with the same point twice. You can't do that. If you have this, you must use slope-intercept. Only other way we got. So here, this whole issue, if you don't have, can you see it right away, by the way? Look at the board here with me. Can you see it right away that you have no constant term over here? There's no constant. Here there's a constant, here there's a constant. That means you could do it. Over here, when you don't have a constant, all of this nonsense is not going to work because of this reason. Because of that reason right there. You have the same point twice. That's not going to happen. Okay, so if this doesn't work, if that doesn't work, we have to use the slope-intercept form of the line. But check it out. That's already in slope-intercept form, isn't it? Why? Well, we're going to make it equals, but let's temporarily make it equals. I'll write this problem over right here. Y is less than 3x. If we don't have a constant term, leave it in y-intercept or make it y-intercept. We're going to set this equal to y equals 3x. Or we're going to make that y equals 3x. Hey, can you graph y equals 3x? What's your intercept there?
0.
Why 0?
Because there's nothing there.
Do you guys see there's no constant, right? That inherently means that you're crossing at the origin. Not sure if you're with me on that. So we had the same situation, right? We know it intersects at 0. If you would have done this, you would have seen that. So since we have no intercept, we already know we're still at that point, for sure. We're still there. What's your slope? 3 over 1. What does 3 over 1 tell you? Are you going to go up or are you going to go down? Up how many?
3.
And over to the...
Right.
How many?
1.
So what this says is from this point, do you see where I'm getting this point, by the way? You sure you're okay with that one? Because some people are like, I don't know where it's coming from. Where this is coming from is because we don't have a constant. It's plus 0. This is of that form, right? This is crossing at 0, right there. 0. The b is 0. And then we're going to use our slope, which is 3 over 1. To go up 3 because it's positive, over to the right because it's over 1. Remember this is 3 over 1. We graph our line. It's certainly not a 45-degree angle. It's much steeper than that. So we would have had the wrong idea if we just guessed at this. Let me graph our line. I need a show of hands to see if you're okay on just graphing this at least. You guys over here? Yes? You guys on the right-hand side? Okay. Is this supposed to be solid or dotted? Good. Why?
Because it doesn't have an equal to.
Yeah, we look right here, or at the original. Okay, so we got that far, but now I have to shade it. Can I use the point 0, 0?
No.
No.
If you plug that in, it's not going to work, first of all, but then it doesn't even tell you what side we need to shade. So if you can't check 0, 0, you can check almost any other point that you want as long as it's not on the line. If you can't use 0, 0, I'm going to pick like 0, 1. That's the one I always go with, is 0, 1. If 0, 0 doesn't work, 0, 1 will work. Unless you have a vertical line at the y-axis, but that's generally not going to happen. Check 0, 1. Identify where 0, 1 is. Look at the board with me, please, real quick. 0, 1. Is this 0, 1 right there?
No.
Is this 0, 1 right there?
Yes.
Yes, that's 0, 1. Don't get those confused, right? Because if you mark down the wrong point, you're going to shade the wrong side of the line. So if I'm using 0, 1, I need to make sure I'm checking that point right there. That's the one I'm looking at. What's my x-coordinate, the 0 or the 1 here, folks?
0.
So I'm going to plug in 0 for the x, and what am I going to plug in for the y?
Y is 1.
So y is less than 3x. I use this, and I go, okay, y is 1, that's 1, less than 3 times 0, x is 0. So I get 1 is less than 0. 3 times 0 is 0. Is 1 less than 0? Is that a true statement or a false statement?
False.
False. Here's what we did. We checked this point right here, 0, 1, because we couldn't check 0, 0. 0, 0 is on the line. Can't check that. We checked 0, 1. 0 for x. 1 for y. That fills out our inequality for us. We make sure we check this down, see if it's true or false. 1 is less than 0. 1 is not less than 0. That means it's a false statement. So here's what happened. We checked this point, and it was false. Are we going to shade the top side or the bottom side?
Bottom.
Definitely. And that's a perfectly fine looking graph. Would you raise your hand if you're okay with that one? Good. Let's try one more of these really to get the hang of this, and then we'll continue. That was such a good example. Things are raining from the heavens. Did you see that? See? That had a little help. Can't believe I just referred to this college's ceilings as the heavens. That's not my idea. Heaven. Okay, anyway. X greater than 3y. X greater than 3y. First thing. Do you think I'm going to be able to use the cover-up method in this example? What do you think?
No.
Do I have a constant term? So even if I were to get this all to one side, check this out. Even if I were to subtract 3y, I would get x minus 3y is greater than what?
0.
That means if I cover up two things, I would get 0 in both of them. This is telling me right here, I hope you listen to this, this is telling me that this line is going to go through the origin. Nod your head if you're with me. For sure. Because those, both intercepts are 0. I mean, you're going to go through the origin at some point. So if this is not, oh my gosh, if this isn't the intercept method, what are we going to do? Slope-intercept. So we're going to temporarily set this equal to 0, or sorry, set the inequality as an equal sign. And somehow manipulate that until you get slope-intercept form. Is this in slope-intercept form?
No.
I need a y by itself in order to get slope-intercept form. How do I do that? Okay, well, I could change sides first of all, right? Maybe change sides. So instead of x equals 3y, I get 3y equals x. We like to see the y on the left-hand side for some reason. It looks more natural to us. But then I don't want a 3y, I want a y. How do I get rid of 3? If I divide, please watch up here for a second. This side is going to be y. Are you with me on that? Right-hand side is x over 3. You can always write x over 3 as 1/3 x. You can always do that. X over 3 is 1/3 times x. Do you see why? If you don't see why, think of this as 1 over 3 times x over 1. If you multiply those, you're going to get x over 3, right? We're just breaking it up. Hey, is that slope-intercept form? Oh yeah, we can do that. So what's our y-intercept? I need you all to participate on this. What's your y-intercept here?
0.
Sure, there's no number over here. Hey, that's why we did this in the first place, right? There's no constant, meaning I'm going to cross at 0. So on my xy axis, I knew initially I'm crossing at 0, but this proves it. I have no number after that x. That means our intercept, our b, is 0. We're crossing at the origin. What is my slope, everybody? 1/3. Am I going to go up or down? How much?
1/3.
And then over to the,
Right.
how much?
3.
No tables, right? No tables. From our origin, because we plotted 0 here, because our b was 0, we're going to go up 1, we're going to go over 3, and we're going to put a point there. Up 1, over 3. Let's draw our line. Leave it solid, make it dashed. Which one? Definitely dashed. We have to also check a point because we need to shade this thing. Are we going to check 0, 0? Hey, look at that. Are we going to check 0, 0?
No.
We can't. It's going right through there. We can't check that point. What point are we going to check maybe?
0.
Yeah, I don't care what point you pick, but be consistent about it. That way you're not just messing, getting all these different points up there. Be consistent. Check one of 2 points. Check 0, 0 if you can. If you can't check 0, 0, pick another one that you always check. Okay? Don't make it something like 1, 1. Make it something with a 0 in it. Because if the origin doesn't work, either the point right above it, that one's probably going to work almost all the time. Unless you have a vertical line right here, that's going to happen. Pick that point. Pick like 0, 1 or 0, 2, something like that. Always pick 0, 1. 0 for x, 1 for y, means that in my original inequality, I'm going to have 0 is greater than 3 times 1, or 0 is greater than 3. Is 0 greater than 3? Is that a true statement or false statement?
False.
Definitely false. Am I going to shade the top half of the line, or am I going to shade the bottom half plane?
Bottom.
Definitely. I checked 0, 1. That's the point I checked. It was false. That's all false. This is all true. And that's how we graph those things. Ladies and gentlemen, do you feel okay with this so far? Okay, now I need to show you one more. You will get some of these on your homework. For some reason, people have a hard time with the next couple examples, so I hope that if you have questions on this, you ask me right now. Because they forget that we can actually graph constants on an XY axis, but they forget how. So let me refresh your memory on how you graph something like x is greater than 3 if I want to graph this on an XY plane. If I want to graph this on an XY plane, the way we do this first, we can deal with the same idea, right? Set it temporarily equal to 0 to get your intercept. You could do that. I keep saying equal to 0. What I mean is set the inequality as an equal sign. Sorry for my misspeak there. What I mean is set that equal to the number instead of unequal to the number. X equals 3 is a constant line. What you need to know is whether it's a vertical line or a horizontal line. What do you think it is?
Vertical.
And if you really think about this, x equals 3, just like over here, well, not there, just like the previous ones we did where we did the cover-up method, you would get x equals the number is your x-intercept, right? You'd go, oh, okay, 1, 2, 3. We put our x-intercept. Is there any y? So
Yeah.
does it have a y-intercept?
Oh, no.
Clearly not. We don't even have a y. How can you make a line through that point that does not have a y-intercept? Can it look like this?
No.
You know what I get a lot of people doing? They go, oh, x equals 3. I'm going to put at x equals 3, I'm going to draw a horizontal line. Well, I'll tell you what, if you do that every time, then all of your lines will be exactly the same for x equals 3 and 4 and 5 and 6, right? That can't be right. Get the same line all the time. That doesn't make sense. If we have an x-intercept and no y-intercept, the only way they can have it is a perfectly vertical line. Is it a perfectly vertical solid line or a perfectly vertical dashed line?
Dash.
Now here's what's cool. This is kind of neat. Remember on a number line, how the arrow told you which way to graph? Remember that? Well, this is basically just graphing on one of our number lines. Notice how it's not even really touching the y-axis. We can use the same idea. This says we're looking for x's that are bigger than 3. Which way is bigger than 3? Left or right?
Right.
Hopefully we get this right. Bigger than 3 is to the left or to the right?
Right.
Right. Shade that side. I can prove it to you with the check if you really want. If you check 0, 0, if you check 0, 0, you'd have 0 is greater than 3, right? Is that true or false? Is 0 bigger than 3?
No.
That would be false. This side would not be shaded, that side would be shaded. Same idea. You with me on this, folks? Okay, let's try one more. Let's do a y one. Let's do y is less than or equal to 2. Well, we do y temporarily equals 2. Y temporarily equals 2, ladies and gentlemen. Y temporarily y temporarily equals 2. Does it have a y-intercept?
No. Oh, yeah.
Sure. Where at?
2.
Clearly, yeah, it says y equals 2. We're going to go right up there to 2. Does it have an x-intercept?
No.
So this is represented by a horizontal or a vertical line?
Horizontal.
Definitely horizontal. Is it solid like I'm showing you, or is it dashed?
Solid.
Solid, okay. Now, we're looking for y's less than or equal to 2. Y's less than or equal to 2. Where are the y's less than or equal to 2? Are they above or below my purple line here? They're below, yeah. The less than 2's, that's down here. This is 1, 0, negative 1. That's all these, right? So if you kind of go like this, Actually, this way. Sorry. If you go like this way, I'll send over here. That's like a number line. Positive, 1, 2, 3, 4, 5. Negative, negative 1, negative 2, negative 3. Less than 2 would be that way. You kind of have to tilt. You have easy. I mean, you can tilt your paper. I have to do this. I'm going to develop like arthritis in my neck from doing that. But it's all of this stuff. And if you check 0, 0, you get the same exact answer. 0 is less than 2? Yes, 0 is less than 2. Shade that side. Raise your hand if you feel okay graphing these single linear inequalities. Now, what we have from here on out, what if we had not just one at a time, but 2 at a time? We're going to graph some systems of linear inequalities. And this is where it gets fun. You guys ready? Fun stuff here. Are there any questions before I go on? Okie dokie. So let's look at systems of inequalities. I'll tell you what. The first part of this looks very similar to a piecewise function. It is not a piecewise function. There are two different functions that we're graphing at the same time. So I know it's a little confusing because I'm going to use the same bracket here, but please refresh your memory on piecewise functions when you get home today so you know the difference between them. On your test, which is on Monday, you will have both piecewise functions and systems of inequalities. You need to know the difference. So check that out. So a system of inequalities says, not only am I going to graph one of these on the graph, I'm going to look at 2 of them. That's why we have that bracket again. All that bracket means is look at these things together. Make sure they're on the same graph. If you have an f of x out front with some directions over here, that means it's piecewise. You only graph little pieces of it. If there's no f of x or g of x and there's no directions past my functions, that means you're talking, and there's inequalities, that means you're talking about inequalities. Okay? The piecewise functions won't have inequalities. The inequalities, well, they're going to have inequalities. Hey, before I go any further, how many people could graph this? Ignore this for a second. How many people could graph that on my xy axis? Raise your hand if you could. Oh, I hope you can. Can't you? Can you graph that? Would the cover-up method work here?
Yes.
Sure. So can you graph it?
Yes.
And could you shade it?
Yes.
Sure. So you can graph that one, right? Okay. Now all I'm asking you to do is graph that one and then do it again. Ignore this one now. Could you graph that one on your xy axis?
Yes.
Would the cover-up method work here?
Yes.
Sure, there's no 0 there. That's great. So our cover-up method will work for both of those. We'll graph those, we'll still shade them. So our steps here are this. You're going to graph each of the inequalities just like you did before, including the shading. Nod your head if you're with me on that. Just like you did before, including the shading. Graph each inequality, including shading. Step 2 is really not a step at all. In fact, I've taught you how to do this already. I mean, we know how to graph each of these individually, so it's not like we're doing anything new. We're just doing 2 of them at the same time. You with me, folks? But we also need to identify the solution set. Here's the idea. I want you to picture in your head what this would look like. Unless these lines are parallel, which they're not, this line's going to be looking something like this, right? And you're going to shade either the top half plane or the bottom half plane. You with me? And this line's going to be looking something like this. They're going to cross somewhere, do you get it? And you're going to shade either the top half or the bottom half of this. Can you see that this shading is going to overlap in some region?
Yes.
It's not going to overlap, maybe it doesn't overlap here or down here, but it might overlap here. That would be your solution set. Wherever you have the double shading, where the shading overlaps, that's your solutions. Those are the numbers, and here's what this represents. those are the numbers that will work both in this inequality and this inequality at the same time. You remember the overlap that we did this? Remember that on your number lines? And you said, oh, this was and, because they worked in both of them. Same idea. Same overlap here. You're overlapping and shading them. So you're going to get those numbers, those points, which work in both at the same time. So where the shading overlaps is your solution set. Let's do a few of these. These actually go pretty quickly once we know how to graph those, which we do. Let's see about this. Let's call this one number 1, and this one number 2, and let's look at 1 first. With inequality number 1, just focus on that like if it was a problem all by itself. First thing you do, what would you do? The first thing you do when you're graphing linear inequality, first thing is what? Temporarily equal. Okay, good. So y minus x equals 4. Perfect. We already said the cover-up method will work. This is going to be kind of a nice one. To find our x-intercept, we're going to cover up what? So we'll have negative x equals 4. If negative x equals 4, how much does x equal, ladies and gentlemen?
Negative 4.
We already have our x-intercept. That's great. In order to find the y-intercept, what do we cover up? So can you look at this and tell me what is my y-intercept? I have my x and my y-intercept. That means I'm going to go to 4 on the x-axis. I'm going to go to negative 4 on the y-axis. I'm going to go to 4 on the y-axis. Add those numbers reversed to my head. I'm going to go to negative 4 on the x-axis. Good catch. 4 on the y, negative 4 on the x. Draw my line. Hey, should my line be dashed or solid like it is? What tells you that? Because basically, I mean, is this new? Is this new that I'm doing? We just finished a whole half a section on that, right? We just did this. We set it equal to, we cover it up, we find our intercepts, no problem. We plot those intercepts, we just did that. We draw our line, you have 2 points, no problem. We make it solid for equals, not solid for not equals, and then we check a point. Can we check a point here? So we're basically ignoring this one for now. We're just ignoring it. It's just there, whatever. We're going to check 0, 0. You're still going to write that over here. You're going to check it in your original inequality. 0 minus 0 is bigger than 4. Is 0 bigger than 4?
No.
That's a false. If that's a false, do I shade the bottom or do I shade the top? Shade the top. Okay, I need a show of hands. How many people feel okay graphing just that one? Good, all right. Now what do you do? Yeah, let's ignore all the stuff we just did. Let's look at that one. We'll do the same exact thing. So here's number 2. Temporarily, we set that equal to negative 2. Temporarily set the equal to negative 2. How we find our x-intercept is we cover up everything except the x. So we cover that up. What's my x-intercept? To find the y-intercept, I cover up everything except the y, including that sign. So I get 3y equals negative 2. Oh no! Is that okay?
Yeah.
Do I leave it like that?
No.
What do you do?
Yeah.
Yeah, we can do that. Is it okay to have a fraction?
Yes.
Let's see about that. Let's see about plotting this. Let's see if I get my numbers right too. My x-intercept is negative 2. That's right here. Make sure you know your negatives and your positives. If you're putting -2 over here, you have the wrong idea, right? It's going to be a completely different looking line. So -2 on the x-axis. -2/3, it's not up here, it's down here. Where is -2/3? Is it is it below -1 or above -1?
Below. Oh,
-1.
above, sorry.
Just a little bit above. So about maybe right there. Do you see that point? So here's -1 and -2. We're just a little above that because we're at -2/3. So far so good? Yes, no?
Yes.
We got fractions, it's okay. We can deal with fractions on a number line. -2/3 is just between 0 and -1. Can I draw my line? Let's connect these two purple dots that we have. See? Always. That's supposed to be straight. Right? It's not for me. It's supposed to be. I can't make any better, I already drew it. And then we still have to check one point. What point are we going to check here? Notice how we're completely ignoring the black shading we just did. We're just working on the purple stuff now. It's like doing two problems at once. You're just looking to see where they overlap. So we're still check 0, 0. Remember, we're checking it now in number 2. 0 plus 3 times 0 is less than or equal to -2. Or in other words, 0 is less than or equal to -2. You suppose that's true or false?
False.
0 is less than -2? No, I'd rather have no money than owe $2, right? That's not true. This is false. 0 is not less than -2. You still with me, folks? So again, we check this point. Did this point work?
No.
So we're not going to shade, look what we're looking at, we're ignoring this black shading, just the purple line. Are we going to shade the top half or the bottom half?
Bottom.
Definitely bottom. This side was false. This side has to be true, so we shade all of that stuff. Now again, here's what the shading represents. Please watch carefully, this is where your interpretation, okay? You gotta know what this means. See how there's no shading here? If you plug in any of these points, remember these are points, 2, 3, 4, 5, 6, -1. If you plug in any of these points, they are not going to work. Not going to work in either one of those inequalities. If you plug in these points where just the black shading is, they are going to work in this inequality, but not in this one. If you plug in this where just the purple is, they're going to work in the second inequality, but not the first. If you plug in these points where the shading overlaps, they're going to work in not only the first one, but also the second one. That's our solution. They're tied together with that bracket, so our solution set is right here. That section.
Do we have to write it like that?
Well, you can spell it out. I'm lazy, but yeah. Write like solution set or
But
something.
that's what you want, a
I
little
want
arrow
that.
showing.
I want you to identify where the solutions are. It doesn't ask for that in the book, but I want to see it.
Can we just shade just that part and show it that way?
That's fine, as long as you put solution set. I don't care. But I want to see that you understand those are the solutions.
Wait, so, like, if we just wanted to show that solution set, only shade that in, do we have to do the other ones too? The ones that show that only work for one function?
You can if you'd like. I mean, ultimately, that's what I would like to see is you understand that,
Concept.
you know, this works for all these points and this works for all these points, but together they work for just those points. That's ultimately what I want to get across to you guys. So I would like to see it that way. If you want to shade just this part and you understand this concept, that's fine. Just understand that that is the solution set. Now, if you shade the wrong one, then of course I give you no credit for that, right? So that's another idea. If you just happen to shade one of them wrong, then you're going to get 0 credit. You don't want that. Okay, let's try one more in our time remaining. You'll see these go pretty quick, right? Not too bad. Let's look at number 1 first. I need you to be able to identify this. Ladies and gentlemen, number 1, is the cover-up method going to work for number 1? What do you think? Is the cover-up method going to work for number 2? Definitely. So number 1, we temporarily set it equal to y. This is pretty much in slope-intercept form already. All I've got to do is flip them around. So I will have y equals 4x. Kind of nice. No, not even any extra work on that one. Can you all tell me what is my y-intercept for this problem?
0.
0. And we got that because there was no constant. There's no constant here. We know we're crossing at the origin. Nod your head if you're okay with that. Okay. What's my slope? So up or down? Up how many?
4.
Over to the
Right.
1. We got that. So 4 over 1, the intercept was 0. Go up 4, go to the right 1 because it's a fraction 4 over 1. So we graph our line. Do I leave it solid? Do I make it dashed? Everybody? Good. And can I check a point? Can I check 0, 0?
No.
What do I check?
0, 1.
0, 1. Okay. Check 0, 1 in this. 4 times, x is 0 here. 4 times 0 less than or equal to y equals 1. 0 is less than or equal to 1. Is that true or is that false?
True.
0 is less than 1. That's true. Here's what you did. Watch on the board here. You checked this point right there. You checked 0, 1. 0 for x, 1 for y, and that said that that point was true. That point's true. Do I shade, let's call this a left. Do I shade the left half plane or do I shade the right half plane? The left half plane. Because that was true, right? That point's on that left half plane. I'm going to shade all this stuff. Okay, we got one more. Number 2, same idea, same exact stuff. We're going to temporarily set it equal to 9. Cover-up method's going to work. So for my x-intercept, I cover that up, I get x equals 9. For my y-intercept, I cover that up, I get 3y equals 9. Or if I divide by 3, I get y equals 3. That's kind of nice. Except that 9 is way out there. X equals 9, that's way over here. Y equals 3, that's up here. 1, 2, 3. And then I graph the line. Kind of a line. Hey, I wasn't able to check 0, 0 here. I had to check 0, 1. Can I check 0, 0 here? So you can use 2 different points. You don't have to use the same point. Remember, I'm ignoring all the black graphing right now. I'm just looking at the purple graphing. So I can check 0, 0 there. If I check 0, 0, it's an original inequality. 0 plus 3 times 0 is greater than or equal to 9. 0 is bigger than 9. Is that true or is that false?
False.
Definitely false. So we checked 0, 0 this time. 0, 0 was false. Am I going to shade the bottom or the top half plane? This was false. Do I shade the bottom or the top? Definitely the top. Can you see my solutions?
Yeah.
All these points will work in both of our inequalities. How many people feel okay with what we talked about today? Do you guys feel okay with these examples? Good. So we're going to work on graphing some linear inequalities. And what we realize is basically, this is just 2 inequalities in 1. If we can graph the first one and we can graph the second one, that's really all I'm asking you to do. I'm just asking you now to put them on the same xy axis. And that's pretty much it. So let's look at our first inequality. I need you to be able to realize a couple things about this. Firstly, with our first inequality, let's call this one number 1. Am I going to be able to graph that with the cover-up method in standard form like we've been normally doing?
No.
Why? It was not in standard form first, but even if it was in standard form, what number would be off here to the right? Well, you would normally have a constant like this one, but up here, do you have a constant?
No.
So that means the cover-up method is not going to work. So when we do this, and we call this one number 1, and we call this one number 2, if we work on number 1 first, sure, we're going to temporarily set it equal to y. We temporarily make that equal sign. Do we ever do this anyplace else besides this one little part? Ever? Never. Just here. We temporarily set the equal. This is just so that we can graph it, basically. And if we cannot do the cover-up method here, even if you subtracted y, you'd have 2x minus y equals 0. Remember, we talked about this last time. If you covered up the 2x, you get y equals 0. Cover up the y, you get x equals 0. That just gives you 1 point, right? We can't graph a line with 1 point. That's not good. So the other option was, whenever you cannot use the cover-up method, we're going to put this in slope-intercept form, which is y equals mx plus b. In our case, it's kind of nice. We have 2x equals y. Let's just flip-flop that equation. Y equals 2x. We already have that thing in standard form. That's great. I'm sorry, in slope-intercept form. Okay, ladies and gentlemen, let's graph this line. Can y'all tell me what is my slope for that function? Great. Someone else tell me what is the y-intercept for that function? Good, 0. 0 says I'm crossing at 0. Hey, that should make sense because that's the whole reason why we're doing this process, right? Because we know it crossed at 0. Actually, instead it crosses 0 twice. We have x equals 0 and y equals 0. That's what we would have got with the cover-up method. Review that from last time. We have already talked about that. So that says, okay, we're crossing our y-axis at 0 at the origin. Next up, we're going to use our slope to find the next point. Again, what is my slope? 2 over what?
1.
Okay, are we going to go up 2 or down 2 then?
Up 2.
And over to the...
Right 1.
That's right there. We'll graph our line. Do I leave it solid like it is, or do I need to make it dashed? What do you think? What tells you that? Okay, so we're not looking really right here, right? That was just our temporary equals. We're looking back up here at my inequality. That says it's not equal, doesn't have that little equals part. So I need to make that a dashed line. Am I done with that? What else needs to be done on this problem, folks? We need to check something. Why do we need to check something? What else do we need to do to make this graph look appropriate? Okay, so we need to check a point. What point do we typically check?
0, 0.
Can we check 0, 0?
No.
No, it's on the line. It's not going to tell us anything. So what point do we check if we can't check 0, 0?
0, 1.
Yeah, 0, 1 will work. Okay, that's have yourself an alternate plan there. If 0, 0 doesn't work, pick another point every time that you can check. I like to pick 0, 1 because I know it's going to work every time. If 0, 0 doesn't. So we'll check 0, 1. That means 0 for x, 1 for y, and we check that back in our original inequality. So that's 2 times 0 less than 1. 2 times 0 less than 1, we've got 0 is less than 1. 0 is less than 1. Is that true or is that false? Make sure you're identifying the point that you're checking. Make sure you know what that is. Because that's important, right? That's going to tell you what side to shade. So we just identified that we're checking 0, 1. That's right here, 0, 1. This point was true or false?
True.
So are we going to shade, let's call this the top half. Are we going to shade the top half or are we going to shade the bottom half plane? Which one? Definitely the top. The point was true. That means all these points are true. We shade this part. Would you raise your hand, feel okay with that part? Good deal. So that was half our problem basically right there. We did our first equation, our first inequality, and now we're going to do the second one. We do exactly the same thing that we just did. It's just we have to do it on the same axis. So it's going to get some crossover, and where actually the shading crosses over, that's our solution set. That's what we're looking for. So let's work on the second one together, and then we'll do one more after that, and I'll let you go on your own. So let's look at inequality number 2. Again, we temporarily set these things equal instead of the inequality. So 5x plus y equals 5 for now. Hey, ladies and gentlemen, will the cover-up method work for this problem? Yeah, because we actually have a constant there. So when we do this, we'll say, all right, if I want to find x-intercepts, I cover up everything except the x. So I write out 5x equals 5. If 5x equals 5, how much does x equal?
1.
Well, there's 1. If I want to find the y-intercept, I cover up everything except the y. So cover up the y to find the x-intercept, cover up the x to find the y-intercept, and there's my 2 intercepts. X equals 1, y equals 5. Imagine if you're still okay on that. Let's plot these things. X equals 1, that says I'm going to be on the x-axis at positive 1. I'll put a big point right there. Y equals 5 says I'm on the y-axis up 5, because it's positive 5. 1, 2, 3, 4, 5. That's way up here. And we're going to graph that line now. Notice how we're ignoring the purple shading and everything right now. We're ignoring all that stuff. We're just looking at this inequality by itself, just like we looked at this one by itself. So we'll graph our line. So far, so good? All right. You mean it's supposed to be solid like that? Oh, okay, it's supposed to be dashed. So go back and make yours dashed. There we go. And we still need to check a point. Can you tell me what point we're going to check in this instance for this inequality? For sure, yeah, it's not on the line. Go back to the 0, 0. You don't have to check the same point in both inequalities. Pick whatever one works for you, whatever one's easiest. In this case, 0, 0 is going to be easiest. The reason why it's easiest is it makes one entire side of our inequality equal to 0. We like that. So we're back here at our original inequality. That's 5 times 0 plus 0 is greater than 5. Or in other words, 0 is bigger than 5. Is that a true statement or a false statement? Definitely. Definitely false. So we checked 0, 0 in this case. We checked that point. This is going to be weird because it's on the other line, right? But you have to ignore that other line. You have to ignore the purple line right now. We're just looking at the black line with our black point over here. So we checked that point. This point did not work. That means that every point on this half plane of our graph here doesn't work for my black line. That means the other side is the side we're going to shade. So we check this point. It did not work for our black line. We're going to shade the other side. That's all this stuff. Be generous with your shading. Make sure you shade a lot. Don't just shade a little teeny part of your line, right? Shade the whole half side. That's what we're doing here. How many people were able to follow that along and get that shading as well? Do you see the solution set? Yeah, it's not here. This is nothing. This is just purple. That's just black. The black and the purple, that's our solutions. Let's try one more together. I'll show you a couple more things on this. I'll let you do a couple on your own. So we got negative 2x plus 5y is less than 10. We got y is less than or equal to 3. Let's see how this thing plays out. So if I look at my first inequality first, my second inequality second, the first inequality is telling me I got negative 2x plus 5 less than 10. I'm going to temporarily set that thing equal because that's how we do our graphing. We make sure it's equal so we can find our intercepts. It's just a temporary step. We don't do this for every time we see an inequality, just if we're trying to graph our linear inequalities on a graph like this. Hey, will the cover-up method work? Yeah, absolutely. So to find our x-intercept, which one do I cover up again? So I'm going to cover that up. I'm going to write what's remaining. I'll be dividing by negative 2. There's at most one more step after that. We get x equals negative 5. At least I have my x-intercept. To find the y-intercept, we do the opposite. We cover up the x term, everything but the y. Still will divide. And we have our intercepts already. So let's go ahead and plot those things on our graph. I know that x equals -5 means I'm going to go over here, -5 on the x-axis, put a nice point. And y equals 2 says I'm going up 2. On the y-axis, I'll put a point, and then we can graph our line. By the way, is it a solid or a dotted line in this case? Solid, everyone needs to know that right now. Dotted. Okay, good. Can you see why it's dotted? Okay, we're looking up here, right? Not right here. What point am I going to check? Let's do it. So we check 0, 0. If we do that, we're going to have -2 times 0 plus 5 times 0 is less than 10. We're rewriting the original inequality. It says 0 is less than 10. Is 0 less than 10? Is that a true statement or a false statement, folks? Perfect. So we identify the point that we just checked. We checked 0, 0. 0, 0 was true, signifying that this entire half plane of that line is true. So we're going to go ahead and shade the whole thing. Hey, we're done with one. They go pretty quick once you get the hang of it, don't they? Cover up, grab it, shade it, done. Awesome. It's kind of nice. Now, the second one, inequality number 2. We have y is less than or equal to 3. Again, we're going to set the thing equal, just temporarily. Just temporarily. Do you remember, that's why I put this one on the board here for us, do you remember what y equals 3 is? Horizontal what? So we have a line there, horizontal line. Remember talking about that yesterday? Got a horizontal line at y equals 3. And you know what, the reason why we can say this is horizontal, if you think about it, there's only a y. There's no x's. So that means if y equals a number, sure, you're going to be crossing the y-axis, y value, at 3. But if it doesn't have an x, that means you're not crossing the x. So if there's no x, can you possibly be like this, or like this, or like this? No, that would be crossing the x. That would say you would have an x-intercept. So if you have no x, there's no x-intercept, that means you have to be a horizontal line. Otherwise, you're going to be crossing that axis. We're going to keep that one solid because of this right here. That says equal, so that's a solid line right at y equals 3. Hey, do we still have to shade it? But you know what? It's kind of nice. If you look back up here, this right here tells you the direction of shade just like a number line would. The only thing is with the y, you kind of have to tilt your paper like this for me. If this is a number line with 0, 1, 2, 3, 4, 5, 6, and -1, -2, -3, all that stuff, this is shading to the left of 3. Left of 3 would be below 3 in this case. Do you guys see that? See what I'm talking about? Otherwise, you could check a point too. You could do that. So if you check 0, 0, if you want to check that here, your x-coordinate is 0. What do you do with the x-coordinate? Nothing. There's no x to plug it into. You with me on that?
Yeah.
The y-coordinate is 0 also. That's okay. This just says 0 less than or equal to 3. Is 0 less than or equal to 3? That's true. We checked 0, 0 again. It was true. That means I'll shade below the purple line. That's what that said. So either way you want to do that, that's fine. You can check the point or you can look at it like a number line. Either way is going to work. Just make sure when you're shading this, we're ignoring the black line right now. We're just looking at the purple. We're shading all of this stuff. Do you guys see where the crossover is on this graph? Nothing's up here. It's not right here. That's just the purple stuff. It's not right here. That's just the black stuff. It's this obtuse looking angle with all this shaded below it. That's a large half plane. I feel okay with these two examples. Good. All right. I'm going to give you one to do on your own right there, and then I'll erase that one and give you another one. Why don't you try these on your own? I'll be walking around. If you need help, let me know. So get started on that one. Bless you. So we're graphing each inequality individually, just making sure we're shading both of them. Where the shading overlaps, that's what we're calling our solution set. Or just say nice. Although I did make a deal with my next class because they always come in late. I said 5 minutes late, you bring me coffee. 10 minutes, coffee and a donut. 15 minutes, a new car. Come on, just a new car. See, I would have been smart and said, like, here's a new car and bring like a Hot Wheel. Yeah. Let's take a few more minutes, try to wrap this up. Hopefully finish the first one and work on the second one. We're going to start on the first one in just a bit. Okay, we're going to start on the first one up here. So first one, we're looking at first inequality, then second inequality. We do them independently. Just look for the crossover. So first inequality says we're going to temporarily set that thing equal instead of the inequality that we have. So we'll have x minus y equals 4 just for a moment, just so we can find our graph. We cover up everything but the x to find the x-intercept. In this case, we're done. That's great. Cover up everything but the y, including the sign, to find the y-intercept. So if negative y equals 4, we know that y equals negative 4. Now we've got our x and our y-intercepts. X-intercept says we're going over to positive x and 4. Y equals negative 4 says we're going down on the y-axis to negative 4. Put a point there. We'll graph our line. Of course, we're going to make it dotted because there's not an equals part up here. So we've got our dashed line. We're good to go. And we're going to shade this. In this case, we can check the point 0, 0. That's great. Zero, 0 says we're going to have 0 minus 0 is greater than 4. That's 0 is greater than 4. Clearly, 0 is not bigger than 4, so we're going to put a false. We checked 0, 0. It was not true. It was false. So this half plane is not acceptable. The bottom half plane, that's what we're going to be shading. And you know, how many people made at least that far? Good for you. That's fantastic. Okay, next up, number 2. Number 2, we have the same exact idea. We're just doing this process twice. So we're going to temporarily set it equal. So x plus 3y equals negative 4. Cover up everything but the x to find the x-intercept. So we're going to have x equals negative 4. No problem. Cover up everything but the y to find the y-intercept. We've got 3y equals negative 4. In this case, though, if 3y equals negative 4, we still have to divide. So we're going to divide everything by 3. We get x equals negative 4, no problem. Y equals negative 4 thirds. Is it okay to have that fraction? As long as you know how to graph a fraction on a number line, that's fine. So x equals negative 4 says we're going over here to negative 4. Negative 4 thirds is negative 1 1/3. So we're going to go negative 1 on the y-axis, and then a little bit more. A third of the way between negative 1 and negative 2. So that's right about there. You don't have to be exact, but don't just put it on negative 1, don't just put it on negative 2, be between there at some point, okay? And we're going to graph that line. Now we're also going to make that one dashed, because again, we don't have that equals. And we can still check the point 0, 0. So 0, 0, we have 0 plus 3 times 0 is less than negative 4, or 0 is less than negative 4. Is 0 less than negative 4? Is that true or false?
False.
Yeah, definitely false. So again, we checked 0, 0. It was false, signifying that this half plane is wrong, this half plane is right. Shade all that stuff, and then right here, that's our solution set where we cross over. Would you raise your hand if you made it that far? You got that. Good for you. You're going to have a problem very much like one of these that I'm giving you on the test. Okay, let's do our last one. We're just going to probably talk about that one. Unless we have a little extra time, then I'll do it for you. Make sure you see at least one example like that. So let's look at inequality number 1 and inequality number 2. For inequality number 1, you're going to see that when you set this thing equal temporarily, we're going to have y equals 6. Well, that's a constant. And we should know right now that graphing a constant, that's going to be a horizontal line at y equals 6. So when we come down here for our graph, this says you're crossing, your y-intercept is at 6. There's no x term. If there's no x term, you don't have an x-intercept. That means the only thing you can draw is a horizontal line. So we'll do that. We're going to keep it solid in this case. The reason why we're keeping it solid is because, well, we have that equals right there. So it says it's not dashed like the previous ones, we keep that solid, and we're still going to check a point. Or you can look at this like a number line. In either case, if you check the point 0, 0, you're going to get 0 is less than 6. That's a true statement. So we should be shading the bottom half of that half plane. If you look at like a number line, it's saying you're shading to the bottom of or to the left of 6. That also says you're shading this part of your graph. Either way, you're shading this. All that stuff. I like those constant ones. Don't you like those constant ones? Kind of nice. Not a whole lot of work. As long as you remember their horizontal line, right? As long as you remember that. Okay, number 2, real similar to some of the other ones we've done before. We do have the cover-up method that'll work here because we have that constant off to the side. So we do the temporarily equal to 10. Cover-up method again is going to work because we don't have a 0 here. Remember, if you do have a 0, or you don't have that constant term, you have to use the slope-intercept form. We've done a few of those examples. Just remember that later on when you get your homework. So cover-up says I'm going to cover up everything but the x to find x. So negative 2x equals 10. If we divide by negative 2, x is negative 5. If we cover up the x, we get negative 5y equals 10. Divide by negative 5. Hey, we get y equals negative 2. So already we have our x and our y intercepts. Imagine if you're still following me on this stuff. I'm going kind of quickly through this because we've done this several times right now. I just wanted to give you some practice on that. So y is negative 2. That's down here at negative 2. X is negative 5. That's over here to the left of the x or the y-axis. Negative 5. We're going to graph our line. In this case, we have to make that dashed. Do you see why we have to make it dashed? Okay. But we can also check 0, 0. That's nice. So checking 0, 0, we're going to get negative 2 times 0 minus 5 times 0 is greater than 10, or 0 is greater than 10. True or false? Definitely false. So here's 0, 0. Why don't you tell me now, if that's false, am I going to shade the top half plane or the bottom half plane? So I'm shading all of this stuff. Wait a minute, that's weird. Do you see any crossover? This is why you have to be kind of generous with your shading. I made this mistake on this graph. My lines aren't long enough, and my shading is not big enough. See what I'm talking about? I need at least some intersection so you can see where the shading is and where the shading isn't. These lines actually continue on to the left and to both of them to the left here, where they cross. And the shading is all of this stuff down here. So we would have a crossover if you continue this. This line would continue, this line would continue up, and our shading would be everything below that part. So if you have your paper right now, continue those lines until they actually intersect. Raise your hand if you're able to get that. Get this sort of graph. Were you able to follow that down, see that it's correct and everything? Okay, good. So do the cover-up method, negative 5 for x, negative 2 for a y. Definitely going like that. Shading below it. Shading below the y equals 6. It's just you gotta draw be generous with your shading. Make sure you see, and generous with the lines, make sure you see where the crossover is. Okay, the last one I'm going to give you up here, I just wanted you to see this because I want you to know there's options on how to graph things. Okay, when you look at this problem, do you see that it's already in slope-intercept form for you? It's already in there. If you are going to do this problem and temporarily set each of these equal, we'd have y equals negative x plus 2. And we would have y equals 2x plus 5. Hey, folks, will the cover-up method work for these two? Does it have a constant?
Yeah.
Will the cover-up method work for these two?
Yeah.
Not the way it is, but yes, it will eventually. Okay, so if you said, no, yeah, you're right, right now it won't. Okay, right now it won't. but eventually it would. So if you wanted the cover-up method to work, if you like that method, here's what you could do. If you like the cover-up method, what could you do to this problem? Just add x and you're going to get x plus y equals 2. You use your cover-up method, you get your intercepts, okay? So you could do that. Add x, you get x plus y equals 2. Hey, look at that. Look at that. Cover up the y, x is 2. Cover up the x, y is 2. You have your intercepts, you can graph that. You with me, folks? Okay. If you don't like that, if you like this, check it out. Could you still get the same line graphing that?
Yeah.
What's your y-intercept? What's your slope? That's down 1 over 1, right? You graph it 2 ways here. I'm giving you options. I don't care how you graph it, as long as you're able to graph it. This will give you the same line. I'll prove it to you right now. If you did cover up, x is 2, y is 2. Here's 1, 2, 1, 2. That would be this line going through those 2 points, right? However, if you graph it using slope-intercept, ignore this part for a second. Slope-intercept says that this intercept is 2, right there. You'd go down 1 over 1. Down 1 over 1. Do you see that you get the same points? Same exact line there. So either way you want to graph that, I don't care. I'm going to give you one like this on your test. That way you have some options here. If you like slope-intercept, great, use slope-intercept, that's fine. If you like the cover-up method, you're going to have to do a little bit of work with it. Just add the x over, but then you use the cover-up method. So far so good? Okay. Same thing would happen here. If you wanted the cover-up method, what would you have to do? Yeah, you would do that. Negative 2x plus y equals 5. Here it would say that your x-intercept is negative 5 halves. Negative 5 halves is negative 2.5. That's okay. Y-intercept is 5. You could graph that on your line. Or you could come back up here and use slope-intercept. What is your intercept here, ladies and gentlemen? Your intercept is not 2. Your intercept is 5. That's right. Intercept is 5. Your slope is how much? That means up or down? Up 2 over 1. You would get that line either way. Notice how this is going to cross at 2.5. Do you guys see what I'm talking about? If you wanted your y-intercept or your x-intercept, it would be 5 divided by negative 2. That's negative 1, 2.5. If you want your y-intercept, that's 5. That's where we're crossing anyway. They will work either way. Now, of course, you're going to clean this up and make, well, these would be solid lines. But you're going to check your 0, 0 in each case. You're going to find your shading, and you would have shaded this graph. In this case, let's see. Well, which one was number 1? Oh, I forgot to use different colored markers.
Number 1 is the one.
This is number 1?
down.
Yeah.
0 is bigger than 2, that's
Yeah.
false, so you'd have this way. 0 is less than 5, that's true. We have this way, so I'm pretty sure, is this one shaded? Is this right? Yeah? Are you disagreeing with me because I'm the teacher?
Yeah.
I'm pretty sure it's that one. That would be your shaded portion there. Double check that for me, let me know if I'm right, because I just did that really quick in my head. It is right? I love it when I'm right. Don't you love it when you're right? Right. Would you raise your hand and feel okay graphing linear inequalities? Sweet deal. That's the last thing that's going to be on your test. So if you can do this, combined with the Chapter 8 stuff, you're going to be good on Monday's test. Now today, for the rest of our day, we're going to start Chapter 10. Chapter 10 will not be on your test on Monday. What we're going to do with Chapter 10 is do the first section. It's just an introduction to some square roots and some radicals, some radical ideas. And that'll be on we'll start on this next week after your test. Any questions before we get going on that stuff?
I did have one.
Yeah.
It's just like whenever you have the number at the end being like less than or equal to 0,
Yeah.
like it makes both of them 0, 0, so I'm just like, how do you...
Right, exactly. If you reviewed last time, when we were here last time, we said if that's ever equal to 0 on the right-hand side, such as this, if that were to be 0, you get x is 0, y equals 0, that gives you only 1 point. You cannot graph a line with 1 point, therefore you must use slope-intercept.
Okay.
You have to use it. I think I gave you an example like that the last part of class, so it would be that one, last time.
Okay.